Right, we should now have some new TikTok stuff. So we've got the viewers on TikTok now, and hopefully the chat messages in TikTok will show up separately to all the other people as well, which is what we want. We want to try and get it so we can actually bring in everybody on TikTok. So the normal chat should show up there at the bottom, and if anybody on TikTok comments, it should show up in a different location now, so we shouldn't miss the chat messages, hopefully. As well as I think any subscribers and things like that should appear as well, if everything's working. This is using a bit of new software, so it might not work, but we'll soon find out. As soon as we start seeing the well, any notifications, I guess I can try and go on and see. Ah yeah, so there's the TikTok messages now. So TikTok is showing up separate, which is nice and easy to see. I'm just going to move them slightly off the edge of the vertical there. So let me just pop over to that. Go to TikTok chat. And then just nudge it slightly over, just so it's not right at the bottom. And there we go, so that's in a better place now. Thanks for the comment as well, by the way. So that's the messages working, the view account now seems to be working, the chat's working, so the only thing left is if anybody drops I think it's like a gift or subscribes or anything like that, or 100 likes, things like that should then pop up somewhere else as well, and show a little notification somewhere, pretty much probably covering my face. Yeah, there you go. So that's like the TikTok stuff, and then the other channels will be in a very similar location. I'm just going to move that down as well, that little animation slightly down, so that'll be TikTok alerts. Drag that down on the horizontal a bit, that was a bit in the way. Lock that, and that's good, so it seems like it's working straight away. And then that's a notification from something not TikTok on that one, so all seems to be working nicely. So at least now we can see a bit more feedback from the TikTok users than considering nothing that was happening on TikTok was showing up, and now it does. So I'm just going to work my way through this a bit, do another few hours on this. I'm just going to break it up into a couple of hours at a time. Yesterday we started transplanting a bunch of stuff over, and now I still haven't found the component tester. Let me have a quick look for the component tester. Favourite current console, funnily enough, I've just brought a Game Boy Pocket Lite off a user on my own Discord. I could obviously make them myself, but this guy's done a really nice job reshelling it and making it nice, like a clear Famitsu one. So I've just started playing that loads now, the original Game Boy screen, but normally it's like PlayStation, Xbox original and Game Boy. But right now at the minute it's this Game Boy Pocket I've just brought. It's just really nice to have the original screen. Let me just see if I can find a component tester anywhere. Well, can't find it where it's meant to be, or where I thought I'd left it. And the only thing at the minute, I'll probably still have to, the camera tracks me, I can't escape. I'll still have to probably pop up the TikTok chat, just because if I walk away and it's gone for more than 30 seconds, it'll still vanish. So I'll still put this. Oops. I've lost the TikTok chat again now, 1 second. Can't remember what the shortcut key is to keep it on top. There we go. Yeah, so I'll still just have to have an extra overlay on the feed, but it's much better now. We do seem to be getting all the comments and everything else from TikTok coming in. We're transplanting all the stuff over from an original PC Engine, customer's PC Engine GT, onto one of our new boards. But at the same time, we are just measuring all the components as we transfer them over and making a bill of materials, so we know all the components that are going to go on this board. And then I can send all these boards back to the factory, the plain white boards, and have them almost fully assembled. So when people buy this board, they've only got to transfer critical components over. But I can't find, at the minute, I was going to look for it yesterday and didn't bother. I can't find a little component tester. And it could be in one of a million places. So, if I can't find it in a minute, I don't think I'm going to. Then what I'll probably do is just leave off the transistors and things, basically transistors pretty much, because that's the only thing I need to test on the tester. So I can't find it. Right, oh hang on, there's one more place I can look. I've also found a little board holder thing I brought a while ago and never used, but that might come in handy. So I'm going to put that back in the tub, but I've got a tub under here that might well have the component tester in. That's just all meters. Is it in here? Yes it is, there we go. Tub under the desk. So we've got a component tester. It's not a fancy one, but for what we need to test and what we're testing here, that's no problem. So we're good to go now, we've got everything we need. And so when it comes to it, we will use that. And let's get started with this side we want to try and finish. If we take a look at this board here, what I'm going to do is just work kind of either top down, like left to right, or top across and bottom. So we'll start with this one definitely, Q500. So he is, it looks alright, doesn't look too bad. So what we'll do is, I think he'll also be disconnected from the board now. Is that fully in focus? Yeah. We've got this trace, that's ground. Then we've got, yeah, that I might have to move that notification out of the way. That's right in the centre, that one. Let me just shift that notification over from the centre view, because that is very much in the centre of my view. Don't know where to put this box. Maybe just shrink it a bit and put it up there, maybe. I'll just move it out of the way for now. So we'll see where that goes. So ground is ground. The middle pin goes to a via under here. Yeah, sorry, we'll take it off to be sure. We don't want to be guessing whether this is fully disconnected. So let's just remove it from the board, and then we'll put it through the component tester. And then you can see now on the top left of the stream as well, I've got a little thing there, that's like the number of likes I think in TikTok. Again, just a bit more interaction for you guys to see, because I get so much activity on TikTok and you don't really see any of it, so it's nice to get a little bit of feedback on the stream. So this is Q500, I better open up that Excel sheet. Q500, and then now we need the value. So this is a bit grimy. This is a repair, so it's a complete move over from the old PCB to our re-PCB, as well as it's going to have a TFT screen, I think it is. It's going to have that added to it, but while we're doing that, what I'm mainly doing here is taking the time to test all these components and figure out the values so that we can pre-populate our new board with most of the components. So you can see this is quite messy, and again, we don't want to over clean things too much before we've tested them, otherwise if we break them we can't test them. So just enough clean for now. And that's going to be annoying, so I'm going to have to keep cleaning my desk. Right, so that's there. And what we do with this tester, again, I'd probably recommend if you were doing this on things other than transistors really, you'd probably invest in a decent tester, but the LCR meter's high quality for testing inductors and caps, but for figuring out what transistors we're using, the cheapest component tester is normally good enough. So I don't bother with, I've tried fancy component testers, but I've never found one I personally like, and I rarely need to use them. So we'll do black, red and green. So you've got inputs on this as well. If we go to here, we do both. We work from home, so I do the repairs from home, and then we have an actual shop, not a walk-in shop, just a unit where packers work from to ship online, like an online business. But all the repairs are done in one room in my house, basically. So you see these numbers 1, 2, 3, 1, 2, 3, 2, 1, 2. They're all repeating. So everywhere there's a 1 or a 2 or a 3, all the 1s are joined, all the 2s are joined, all the 3s are joined. You can put the components in anywhere. A and K is anode and cathode for testing diodes. So basically we're just going to put the 3 leads in, 1, 2 and 3, and then remember the order, because when it figures out what components are, it shows up on screen and says, you know, pin 1 is this, pin 2 is this, pin 3 is this. So that's the only relevance. You can put them in any order, but it'll tell you on screen what the pins are. So put them all in, latch them down, and now the job here is to try and grip on, and there's some test components. There's some spare prongs. We want to try and grip these little grippers on the component, which is the fun part. So we will see if we focus that down, bring this in. What we've got to try and do is get this on one of the legs, and we might find that because this is so small, we will have to possibly, although that's got it quite well, bring the focus up. You can see that's just about grabbing on there, but I think it's going to touch, almost touching. Yeah, I think we're going to play it safe, I think we'll have to attach little wires on there, otherwise we're not going to get it. So just just going to take us a little bit of time with these surface mounts to test them, because we're going to have to attach wires to each pin. No, this is definitely not cost effective what I'm doing. Morning in Leonardo, just noticed that. The reason I'm doing this is just to help everybody. So this is to help everybody and also make our products better. So we know what all the components are on the PC Engine GT and the values, because nobody's done this. If they have, I don't know anything about if they have done it, or if it's accurate, because it's also not me doing the work. So we basically want to figure out what all these components are and the values, and then people can buy replacements if they lose the components, and we can pre-assemble the board with all the components on. So this is going to take me probably 30 times longer than just doing it without measuring all the components, but in the long run, the next board I have to do for a customer is going to have all these components already soldered on from the factory, and this does not want to take solder because it's dirty. That's the other downside, because it's got that corrosion on. It doesn't even want to attach the wires to it very well. So that's that's not going to work for. Just going to have to let the flux go onto my desk. I was trying to prevent the flux going on my desk. There we go. And this is just difficult to tack on because it's still barely tacked on. Yeah, look, it's just because it's got dirt. I'm going to have to clean the pins then. I was trying to not risk damaging it by not cleaning the pins, but we're just going to have to really clean them pins up. Otherwise, we're not going to get wire attaching to them. So probably on the next ones, this is all the electrolyte on the transistor as well from the leaking caps. So that's the issue we've got here. But on the next ones, I'll clean them up while they're still attached to the board. Save doing it off the board like this and messing up the nice silicone mat, because you get the mat too dirty and it can stain the mat. Two streams, we've got a horizontal and a vertical, and then it's streaming across everywhere. So TikTok, Twitch, YouTube, Facebook, I think that's it. Right, these pins should be clean enough. Now we should actually be able to attach a wire nice and easy. Well, as easy as it gets attaching a wire to a tiny chip, but it shouldn't be difficult. There we go, so now it's tinned up. So you can see the difference with how it's actually tinned on. I can zoom in a little bit more for you. You see you got your nice solder ball on there now, so it's attached. But you saw how difficult it was to attach without the board being clean. So that's why we really got to. It takes a lot more work once you're working on a board with like electrolyte rot. Everything's a lot harder. Components rot, pins don't stick, pads rip. This is why you want to do the recap really before it actually happens, because it makes everything else harder. What console are we on about here? I won't remember, unfortunately. There's that many messages I go through every single day. I think I worked it out the other day. I was searching on like emails and I accidentally searched all, and I think it works out I do about 89 customer emails a day, 7 days a week, in between all the other work. So it's no wonder I forget everything else. So that's why I can't remember birthdays. That's my excuse. Right, I think that one's on. Game Gear and what we issues. Just go through your issues again and we'll diagnose. I don't think there's a way. If you've got a way, share a link as well. Feel free to share a link to like an image or something, or a Discord post if you've posted on there at all, and I'll have a quick look in between stuff. do you get game audio as well? Basically, the first checks I'd do either way in a game gear is turn it on, make sure you get red light boot, so make sure your red light's coming on and staying on, and if it is, do you get game audio? If you've got screen issues, ignore the screen for now and see if you're getting game audio, and that basically tells us if the console's running properly with game audio. Otherwise, I wouldn't even bother diagnosing a screen until you've got full working game audio in a red light, because the screen will just do anything random until that point. Right, so hopefully we have got to do this quite a few times. I was going to say hopefully we haven't got to do this amount of work on every component, but looks like all the transistors are like this. But the benefit here is I'm going to have these wires pre-stripped, pre-tinned and saved in between testing, so all I'll have to do is tack the 3 wires on, and I'll leave them attached to the tester as well, so it won't be anywhere near as long as this then. We'll just have to tack 3 solder pads on each one. And the middle pin is attached to the tab at the back as well, so that is effectively the same as that middle pin. And for those joining in a bit later on TikTok, you can see now we've got a ton of stuff from TikTok. We've got the viewers now showing up the top. I don't know why I'm pointing because it's 2 different streams, I can't really point at it, but top left there's the TikTok view counts now that work. Top right is the TikTok viewer count. Top left is the likes, I think it is, in TikTok, like the top 3 likers. We'll get notifications when anyone subscribes, GIFs, things like that. They should pop up on stream, and the chat is now separated, so the TikTok chat shows above all the other chats, because it just wasn't merging incorrectly using this Streamlabs thing. So now at least we should have all of that working for everybody, so we can get a bit of decent interaction between everybody else, because there is a lot of activity on TikTok that's just getting missed. So I quickly set all that up this morning. Right, and then when we strip these ends, I will fold them over and make a bit of a ball so that we can actually grab onto them with the component tester, or just try and get extra solder to stick to the pins is the goal. But I'll normally make a little loop in the wire and then fill it with solder to make like a little tab. That's how you make these thin wires thicker. So we've got this thin wire. Yeah, I've been in bed. In bed about 11 o'clock. Up about 5, and then I've had to spend about an hour getting all this new TikTok integration working. And I'm just going to do a few hours on this, and then get on with software. I've got a lot of software work I've got to do at the minute, pretty consistently. So I'll be jumping off probably 8-9 o'clock, get the software work done, and then be back on maybe in the afternoon and carry on. So that's like how I do a little ball. So now we've got a thicker bit to grab. This one's ironically ended up with that entire dry solder ball coat on it, but that won't be that ideal, so let's get rid of him. Just do the same on this. And like I mentioned, this is only going to be all this work to just test one transistor. Most of this is in figuring out the best technique and making this little wire harness. Once I've done this, testing the next transistors will be a lot quicker, so it's not going to be this slow. I've red light boot but no sound. Yeah, so ignore the screen completely then if you've got no sound but you've got red light boot. Go to the wiki and go to reading game cart. You need to check if you're comfortable in reflowing the A6. I'd reflow the A6 just to be safe. Reflow the Z80. If you don't want to do them, then you don't need to, but that's the first recommendation. Clean your cartridge port with vinegar, like white vinegar that's warm. Put vinegar in the microwave in a little bowl for a minute so it's like pretty hot. And then you can either tip it in the cartridge slot slowly so it like touches, but ideally you want enough vinegar that you can dip the cartridge connector in vinegar and leave it for like no more than a minute is more than enough. And then once you've done that, inspect the cartridge port. You could always try and bend the pins up with a tweezer, and then try again, clean your game with IPA and see if you get game load. If you still definitely don't, then you need to start going through that reading game cartridge wiki and testing every single pin is good. Basically, you're looking for a broken trace between the Z80, the A6 and the game cartridge slot. You'll likely have a bad trace between them. Or, unfortunately, with no screen to even see what's going on, you could also be dealing with bad ASICs, and it's almost never the CPU. It could be the Z80 and it could be the VDP on the right. We've seen the VDP fail tons, but most often no sound is one of them traces, the game cartridge slot or the Z80 bad. We are making a PC Engine GT, so this is the customer's PC Engine GT that's having a complete swap over to this board, but in the process of doing that, I'm identifying every single component on the board so we know exactly what type of component it is. And then that means I can get these whiteboards pre-populated basically with all of my components. Have you repaired? Oh, I've missed a few with not looking at the chat either. Have you repaired many handhelds now? The market. Oh, handhelds, thousands, tens of thousands potentially by now. It's our biggest thing we do. Literally every single day, without fail, for 7 years we've repaired Game Gears and Game Boys and all sorts. Morning, welcome in. We've got all new TikTok stuff now, so you can see all the likes and all that kind of stuff shows up. A bit more interaction. I got into this work just myself. I'm self-taught with everything, and it's just something I wanted to do. I'd done software for probably 7 years. Again, at that point I kind of go between doing software businesses and then other businesses because I like to do a bit more hands-on and physical than just the software. PC handhelds and the PC engines. Yeah, I've probably done about 20 PC Engine GTs, mate. Well, probably more than that over the years, but I'd say I can probably safely say I've done 20 of them. Right, so now we have this little jig. So this is what we were after. We have, is that as far out as we can go? There we got some nice view. Let me clean that desk and it's going to drive me nuts otherwise. I know this is going to get constantly dirty, but still want to keep it clean. Right, so we have I can't read that, but I presume that's like welcome, saying hiya from Romania. So welcome in, if so. I'm guessing that's what it'll say. We got this component. This is Q500, and now we have the legs here. So say we call this pin 1, 2 and 3 if we wanted to go in the multimeter or in the multifunction tester. So pin 1 is going to be black, 2 is red, 3 is green. So we'll go black, red, green, left to right, and then when it shows up in the tester what it is, we can quite easily remember the order, left to right. So we will grip on this one, grip on this one, and then grip on the last one. And then it should be as simple as turning this on, and so long as the component isn't bad, it should tell us it's a transistor of some kind. So if we press start, you can see it's going to test. And there you go, it's found a bijunction polar transistor, and it's an NPN, and we've got a voltage base to emitter of 0.65, so pretty standard, and a current passing through in order to drive it at point. So it's completely bog standard NPN transistor basically. So we'll write those values down in the spreadsheet that we're making, but that's pretty much just completely standard value. So if we actually keep that over there so you can see, and then we're just gonna how do I zoom in Excel? Apparently I can't. I thought I could zoom in visually. There we go. So a bit zoomed in for you there. We've got Q500. What we'll do is put a note here, well actually we can put in here just an NPN, Package sizes will work out another time, we don't need to worry about the package sizes. So it's just an NPN transistor. In the notes we want pin 1, 2, 3, left to right. And we'll know that because looking at a chip, I would naturally look at the chip in this orientation, so I don't need to write down what that is. And then when we tap this now, we can then put after it. The only important thing here is the voltage from base to emitter is 0.65 volt. That's all that matters for resourcing this NPN, and what I'll do is spec it way above spec anyway. So that's now one done. This isn't a mod we're doing, this is just testing all the components on the PC Engine GT one at a time to identify what they are, and then making a spreadsheet of them so I can populate this PCB that I've got, this re-PCB, with all the components that can possibly go on. At the minute we're going to have to hand solder all of the components both sides, and we don't know what they are, so we're transferring them over from a customer's board. But I want to spend this time in identifying all the components on there so that we can transfer them over and have a factory pre-assemble almost every component for us. So this little tester just literally identifies chips by running common tests to see if it's a diode, a transistor, a resistor, a capacitor, an inductor. It runs a bunch of little tests on it and quickly identifies what the component is. So once we've identified one, we take off the legs. I've left all the wires on here and left the component on the board. So when we want to test the next one, all we've got to do now is quickly blob those pins on. And then what we want to do here is transfer that over to the actual pad on the board so we don't lose it. No, I've been in bed. I didn't stay up, so I got up about 5 o'clock. Just going to do a few hours before I start doing some software. There we go. And this is where it wants to go, Q500. So what we'll do here is pre-tin these pads. Get a little bit of flux. Grab the hot air, and we'll reflow him on. So this is nice and easy work. Nice easy work for the morning. I'm just holding it in place with the tweezers until I see some of the solder flow, like there, and now I can let go, and there's the dance that shows it's all soldered in nicely. That dance is showing that surface tension is pulling the chip back into centre of the pads, so you know the solder's good. There we go. I love how this board cleans up. Just literally wouldn't know we'd been working on it. That's the goal of this. I want this to look that clean, it's almost like a factory. So that's one down. Well, one for today, that's the first one. And now let's see what's next. So we've cleared everything. Oh, we haven't. We've got D502, so this is going to be a diode. So even though there's 3 pins, this is just standard in the package, that sometimes you have a 3-pin package for diode. Not so much these days, but much more common in the 80s and 90s, reusing packages that existed. So this is, well, actually, I don't think this is a diode, even though it says D502, because 3 pins are connected. Or it could be a diode with 2 packages. Yeah, so there's 3 pins being used. So I'm guessing this is potentially a dual diode in a package, so there might be. This will look like, see, it looks like a transistor to me. It looks like it's going to ground here, which would normally be the base. This would be the, this would be the base with the thin wire. This would be the collector to ground, and this would be the emitter. So to me, this looks like a transistor. This looks like an NPN transistor. I want to first try and get all that grime off the pads though. So I'm just going to put some flux on and warm up this to try and get rid of that corrosion on the pins, because you saw the issue we had when we took it off the board before, is that all of the corrosion on the pins prevented us soldering the wires on, and we want to be able to solder them wires on clean. So we'll get this bubbling up, try and scrape some of that corrosion off, rub it in the flux, and that's as good as we're going to get without overheating the component there. And now let's do the same thing. I'll bring in the component tester, and we will solder these pads, or solder these wires onto the pads. So the black one, which has now come out of the other side of the tester, wants to go on that little pad there. Let's zoom in. PC Engine's like a Game Gear. It plays the games off another console called the PC Engine. So this is the PC Engine GT. But it plays, I'm going to have to go on max magnification here to get this. In fact, that's going to move as well. Ah, that's hot. I want some blue tack, which I don't think I've got lying around. Wonder if that little board I've just grabbed is going to be useful here. Or more so, this little weight. Oh no, it's well actually, that might not be a bad thing. This is magnetic, just a little holder. So this is kind of stuck to there, but that will actually hold nicely while we solder the wire ones. That's kind of worked in my favour a little bit there. I wasn't planning on doing that. I was planning on it weighing it down, but well, no. The soldering iron sticks to the magnet as well, so that's out of the way. Normally when I'm working on tiny chips like this, I just use blue tack. I just need to see if I can find some, because this is just going to disappear when we come to solder to that. Or what we could do, tell you what, another trick. We can get this board. It doesn't matter what pin we go to. I'm going to tack on the components to a random pad. Where are we? Just tack on to say, that's a ground pad. Let's go to this pad, pin 7. Blob solder on that so it holds it in place. And now I can blob solder on the end and attach a wire. So we're going to get pin 1 on this pin here. We are transplanting chips over from an original PC Engine GT. Well, my soldering iron tip is failing again. I think I need to buy some new arms for these irons. Right, so pin 1's on. We can then turn this around, move it slightly, put pin 2 on, which is red. How did I learn? All self-taught. So doing what I'm doing now, things like this, just figuring stuff out in small steps. No training at all, just years of messing around. It's not something that come overnight. I've been doing it on and off for like the hardware side for 15 years, so everything's easier with time and practice, and then it just looks a lot easier when you observe it and you see what I'm doing. But it's a collection of knowledge for many years of work. Right, it's this last one now. It can't fly off now because we've got 2 wires on it, so I'll just fumble around with my fingers holding everything in place and tack that wire on. So there we go, that's the 3 wires attached again to this little chip. Same again, I don't think this is a diode, I think this is an NPN transistor, labelled wrong. Yeah, look at that. And oh, I know what we didn't do on the last one. We didn't write down the pin order. Does anybody remember? Or I don't know, you can scroll back and screen. We'll have to go and find the pin order. I didn't actually write the pin order. I wrote 1, 2 and 3 down, then didn't write which pins were which. So in this case, did I get the pins right? Where I said the center pin, pin 2, would have been the base. I didn't, so pin 2 is an emitter. See, that doesn't ring true either. I don't know how much I believe that, because pin 2 is the thin trace on the board. Let me see what I think about that. Full-time job this, is it? I do multiple things. Oh, welcome in from Ecuador. Audi S7. We don't work on anything now bar the retro consoles and stuff because we're too busy. So it's something I could probably work on, but we don't, unfortunately. We just had to make a choice to not work on too many things because we're just too busy, basically. Just need to check something a minute. I'm just going to look at the Gerber files of this board I've made because I want to see where D502 goes. I just don't believe that is an accurate thing. So just give me a minute to try and hunt down a bit more info. I don't trust that test, basically. I don't think it's a diode. I think what it is a dual diode, and this test is getting confused and thinks it's an NPN transistor, because that's commonly how it'll test for an NPN transistor. It is by testing if two ways are diodes, and then if you can put current through one way. So I think it can misrepresent, with it being a cheap tester as well, I think it can misrepresent the actual component. So let me just do a little bit of digging a minute. D502. Considering it's D as well, it's a big hint that this is just a transistor. A dual diode package. I'm almost absolutely confident of it. So if I can find out where it goes and understand the circuit, I can be even more sure that that's the case. And probably an expensive or a more expensive component tester, this is where it would detect stuff like that. It wouldn't make these kind of mistakes, I'd presume. And we are, I keep forgetting what we are, D502 was it? Yeah, D502. Yeah, so I think this is a forward follow tap off as part of, God knows what this is for. Something to do with the transformer T500, so that's going to be something to do with I want to say the contrast circuit, pretty sure. So I don't think this is, it definitely isn't a transistor, so this is the wrong test, if you will. This thinks it's oh yeah, the hint there, actually, if you look on screen, 0 current through. So that's actually one way you might tell. If the IC, it's got no current passing through, it's not going to be a transistor, because there's no point in a transistor with no current. So this is going to be two diodes. Now, the easiest way to find out if it's like which way the diodes are is take one of the pins out. And probably easier to disconnect it the other way then. So now it's just got pin 1 and 2. And this should identify it as a diode. So there we go. So now we know pin 1 is the anode and pin 2 is the cathode. So on my sheet I can do D502 dual diode pin 1, 2, 3. I'm not going to write left and right now because that's going to be the same for every one. Pin 1 is anode, 2 equals cathode. The breakdown VF is, what was that? 1.2 was it? 1.4. And then pin 3, we can now do, this is how we find out which way around the pins are. If we put pin 3 back in now, and take out, say, pin 1, and test again. At some point we should get a double. In fact, we might have already been double there. So that is now pin 3 to 2 would be pointing in. I'll draw this up after so you kind of see. This would be an anode on this side with a VF of 0.7. So I think it's 2 diodes with a 0.7 volt drop. But when we're going over pin 1 and 2, it's going over 2 diodes. So I think pin 1 and 3 will be a 0.7 volt drop diode. Yeah, so there we go. So pin 1 and 2 is spanning over both. And pin 2 to 3, pin 1 to 3 is the other diode. So let me draw this out. It's easier to think about this visually. So we have what we've seen. We have a package with, say, this is the package, 3 little pins there. So that's the package we're dealing with. This is pin 1, 2 and 3. We've got pin 1 and 3 in at the minute, so we know there's a diode going between them. And that is going pin 1 to 3, like this. So we have this one coming out, going down, and pin 3 like this. Now, if we remember, pin 2 and 3 were also a diode, and pin 1 and 2 managed to span both. So that would be pin 2 and 3, if we put it back in just to definitely get this right. Taking out pin 1. So pin 2 and 3. 3 has got the diode coming off, going to pin 2. So if that's right, we've got something like this in a package, which means, drawn a little bit easier, they've got an inverted pin like this. So we would have, typically, this would say go out here, over to there, and that would be this diode going over to there, which is pin 2 over here. Then you've got the common point here going back to another flat, so that would be a flat like this, going over to pin 1. So that's pin 1, pin 2, and pin 1, yeah, pin 2 over there, and this shared pin is pin 3. So that's basically how you draw it in a schematic. You've got a diode here passing through, and a center tap here. So this will be for probably the H position of the, I'll write that down actually as well, D502. That'll be for like the contrast of the circuit, I'm guessing. But that's how you can be easily tripped up by thinking it's a diode, a transistor, not a diode. Welcome in from British Columbia as well. Yeah, you can send the Game Gear to us, no problem. Just book it in with requires diagnostics. Right, so for what I'm going to do is I'm just going to put dual diode, pin 1, 2, 3. I've obviously got the diagrams and things and I know what they are. I'm just trying to think how to write it the best way. So 1 equals anode, 2 equals cathode, 3 equals shared pin. So basically that will mean whichever one was an anode, the other one would be a cathode. So I think that makes the most logical sense to me. We can keep this diagram as well in the collection of stuff that we're working through. But I'm confident that is what that chip is. So now we can put that on the board as well. What device used? Using the big clamps that are siding to this thing are we on about? Big clamps. What device is using the big clamps that are sitting on your silicon mat? Oh, you mean where's my zooming out thing? You mean this? This is it's called an LCR meter. So Al is for an inductor, C is for a capacitor, R is for a resistor. So they call it an LCR meter for testing inductors, capacitors, and resistors. This is a high quality one because testing. Yep, see you in a bit, Leonardo. Thanks for joining in. you need to be accurate when you're testing things like capacitors and resistors and inductors, so I've got a nice expensive meter for that. When you're testing components otherwise, like transistors and diodes and things, I've just got a cheap little meter. Might invest in a more expensive one at some point, but I rarely need it, so it's just not something I've ever bothered looking into, like a high quality component tester. And to be honest, I don't know, with them using like, you know, tricks and techniques to identify chips, most open source stuff these days is probably as good for component identification as it is for buying a meter from a branded company. It's not like it's that specific about testing the item. It's about identifying the item. So you don't really need high quality internals. So that ultimately just means that buying a cheap component tester is probably as good as an expensive one for the most part. Whereas buying a cheap LCR meter is nothing like buying a good one. So it's just about knowing where I want to spend my money and not waste it, basically. Alright, so this one is going on this pad. This is a small pad, so I'm going to add a little bit of extra flux to help it along the way. That's the pins. And now we'll flow him back in. And if it wasn't for the fact it says D502 here, we might have been tricked into thinking that was a transistor, but I did notice that it showed up as a 0. Afterwards I noticed it showed up as 0 current passing through the transistor, which was a hint that it wasn't a transistor as well. Might have been a quicker way to identify the diodes as well. And then I'll just have to look back on the stream when I'm done for Q500, because I forgot to actually write down which pin, you know, pin 1, 2 and 3, which was the base collector and emitter, I think. I don't know whether I looked at it and said I was right, but either way I didn't make notes, so I can't remember what that one is. But I've got it recorded, so I'm not going to take it back off. I'll just look back when the stream's done where it was. Oh, that's them two. Next up we have all that's done. Scream if I miss anything if you notice components still on the board, but I think we're done up to there. We've got one little resistor here. Resistors are nice and easy. You don't normally need to take them off, but because we want to make sure all our measurements are accurate, we will. And it also says on the component what it is. So typically, if we zoom in extra here, see the writing on the resistor says, oh, you would there, you can see it. It says 154, so the first two numbers are just the numbers, 15, and then the third number is typically the number of zeros to follow. So 15 and then 4 zeros would be 150, 000. So this would be 150k based on if those numbers are what they are. There's various different annotations for resistors, but that's the most common. So to test this off circuit, I'm just going to move this off. And to be honest, I originally said I wouldn't use these components. We'll swap them for new on this board, but we're literally testing them, so that's kind of the point, to test they're okay. So for this one I will, you know, I'll put the components on. It saves me a bit of time in also hunting for every single resistor of a specific value that I might not even have as well. So now we can test this equivalently as if it's not on the board, because one pin's floating. And there you go, 150k. So you can rely on the readings and be confident and just swap them, but I want to be very accurate on this. I want to take my time and make sure I've 100% seen every component is what it says. So let's pre-tin this board now, ready for accepting the new resistor. Solder on there. I'm just going to hot air this one off and onto the board. Well, I don't even need to hot air it off because we've already lifted it off, so just take it off like that. We'll put a little tiny bit of flux on, which this is definitely my new favourite. This is better than the last one, so the high temperature flux is one of my favourites so far. Hey, welcome in. Yeah, to be honest, this is nice, easy work. It's oh, we've got way too much solder on them pads. let's push down, and I'll use the iron to clear off that extra solder. Who says you can't have too much solder? You definitely can. Right, there we go. Now it's got less solder. We'll just reflow that a little bit. I think the resistor already had solder on, so we ended up with way too much there. Yeah, still a little extra blob on one side, but I'll clear that off in a second. There we go. Nice little resistor. Right, so, oh, wrong side. Where have we gone? There. So there's nothing on here, nothing there, resistor's gone. So do we work down here? Ooh, looks messy. I think we go across. Even worse. Okay, let's do this pot then, this little potentiometer. So this is just similar to that volume wheel that we melted the shit out of yesterday. This is basically an equivalent thing, a 3-pin. So just like the wheel, you'd have a resistance over here, a little carbon pad inside, and this arm would swipe in the middle. So it's exactly the same as that wheel that I showed you yesterday, just in a baby package. And they're always the same pinout, so you don't even need to bother with detecting pinouts and stuff or making notes. These little pots are always the same. The outer two legs are the overall, and the middle pin spins around. So all we need to do is get the normal multimeter, measure over these pins, and it should tell us a resistance. Now this is telling us 2K, and that's not a standard one, so we need to take it off the board because the board can be interfering. I think the board could interfere with this reading. No, it can't really, because it's a pass-through. So that's saying 2K. I don't necessarily trust that. 2K is not a standard. Actually, it might be. I'm saying it might. It's not. It might be close to 2K. There'll be something around the 2K mark, but let's clear up them pads. Test again. 2.25K. So let's have a look at my little tub of potentiometers somewhere up here. Oh, it is. There is a standard 2K. I stand corrected. So we have in here a little tub full of all little baby ones, so we don't want to tip this up, otherwise they'll all fly everywhere. But you can see, I just have these kits made for me. I just tell the factory make me up little baby kits when I'm after things. So I've got nice, easily accessible things. So the 2K is down here, and in this case, because that does look grimy, we're going to grab a nice fresh one. So this is a brand new one. And then before we forget, I will make a note in the BOM because we forgot to do the resistor and this. So we've got R515, and that is, what did we say that was? Was it 150K? Yeah, it was 150K. This is VR501, and that's going to be a 2K pot. And then what we'll do is solder this on our board, and we'll just take it off the customer's board because we don't want to keep looking at things that are still on the board and getting confused if we've done the work or not. These can be hot aired on, so long as you don't take too long you can melt them. But if you know what you're doing, hot, hot, hot. Just as I say, if you know what you're doing, I flick solder right on my finger. Right in between the grooves of your finger as well. It always goes on the hottest spot. Went right between there. boiling solder. So now, if we've got that on, we can hot air this on. If you're going to hot air these on though, I tend to, just because these are some things that can be sensitive to heat, warm the pads up first, and then you're going to have a temperature difference between the component and the pads, but that's fine. Warm them pads up, try and blow that flux back over while we're doing it. That's it, and now the pads are liquidous. Plonk the pot on and nudge it into position. A little tap down, and that's the potentiometer in position. Ooh, I didn't realise I could do a little dock, that's way better. Yeah, I'm sitting here with a TikTok chat pinned, and I'm forgetting this software I'm using, this Tickfinity, can actually give you a little overlay, a little dock if you will, that lets me see the chat much easier, instead of it mixing it in with like likes and things. So let's see if that works better. Can we add a dock in? Does anybody know if you can add a browser source in? I'm pretty sure you can in Streamlabs. Don't know whether I want to mess with it midstream like, but let me see. If it's easy enough, I'll just chuck one in. Expand this. Layout editor. I'm risking it here doing this mid-flow. Add tab. Editor. Yeah, I won't bother doing it mid-flow in case something goes wrong. But I will place this new chat window easier. Because the little... I don't think TikTok's kind of... integration is that good in terms of like when you've got a live feed going and you're trying to see like chats and things. I don't think it's the best because it does mix, like, you know, the chatting with all the likes and things, and then they're no different in colour, so you can't easily see if I miss it on screen. But I'm using this new Tickfinity thing, and it's really good. It's worked great so far for this stream. Oh, we didn't clean that off with me messing around. Let me warm that back up a bit, otherwise that flux is going to be... Well, tell you what, let's see how hard that flux is to clean off. Cool. Yeah, a bit harder. So let's just warm this back up a bit so the flux melts, and we'll clean it off better. Yeah, that should be enough. There we go, another one clean. So now on the customer's board, we will just take that off. That's destroyed anyway, it's rotten and horrible, so we'll just get rid of that. That one gone. Next up then, we have this resistor. While I've got the hot air out, let's just nudge him over. Yeah, there we go. And then we will measure the resistance of this one. Again, this is going to be warm, so don't measure resistor while it's warm, it'll change the resistance. So let's just wait for this to cool. I can give it a measurement now and we can see. So it's measuring 1K. And it's quite warm, but if we look at, we know it's measured 1K, and if we look at the writing on it, we can see it says 102. So that's 1 0 and 2 zeros is 1000, which is 1000. So even though we should wait for it to cool for the value, resistors pretty much tell us what they are on there. So we know that's a 1k resistor, so we're good with that. Let's not forget to make notes. R506 is a 1k. This time, because this has already got solder on, I'm not actually going to apply, but I'm going to try apply just a tiny smidgen of solder. We don't want too much on these pads, so that's probably easier said than done. Just a, there we go, like a wafer thin amount of solder on there, and then when we move this resistor over, hopefully we don't have huge amounts of solder. Want to try and not warm up the potentiometer much, but this shouldn't take long to get on. There you go, see it's flown into position. That's already liquefied, and there we go. Another resistor on. What do you mean by drop solder? I'm all self-taught, so if there's any terms that people use, I probably don't even know them. I'm just literally, everything I do I figure out myself and do it one way. The fuse, we can just replace. We know that's a 1 amp fuse, we can chuck that on now. There's stuff underneath, so I'm not going to put the switch on yet. Solder drips, like by mistake or on purpose. Obviously, if you put solder on the iron tip, it'll just obviously melt and ball up, but if you just shake it, it'll fall off. So that's just made a solder blob over there. I don't know whether that's, if you're meaning how do you get that happening, or if it's on purpose or not. So fuse, I'll put it in the notes, it's a 1 amp fuse. We're going to put a resettable fuse on. Now the only downside I will say to resettable fuses is they can add a little bit of noise to the system, because they act almost like an inductor. So we'll do 1 amp fuse, and I've seen a ton of them recently and I forgot where they are. Where did I see an absolute ton of them? Literally bags full, I can't remember, I think they're in here. There we go. So this one I'm also going to uprate slightly. High temperature, you don't ever want a drip as such, it's never a thing you'd want. In terms of temperature for the iron, I say work as hot as, oh, it's buggered off. I say almost work as hot as the boards can bear, or that works with your workflow, not the opposite where people will work as cold. So a lot of people will try and set their iron to like 300 or something, but I find the hotter your iron, the better things flow, the faster you can work, the less heat transfers to other areas of the board in general. So it's all preference, but I run my iron at 390. I used to run it at 420, but the only downside is at 420C the tips burn out because that is quite hot. But same with the hot air, I work hot. Everything I do, I pretty much work hot and fast, if you will. I guess is probably what people would class it as. This fuse is a 1.5 amp. I'm going to uprate it slightly because it's going to have a TFT screen on here, a modern screen upgrade. So we don't want the fuse constantly tripping or blowing or running close to power if it does draw a bit more power. So we'll just push him through the board, and you can see he just sits nicely in there. Pull focus up. Like that. I love how sharp this camera is. Something really nice about just looking at clean white board. And then I've bent the pins over there just so it stays in place while we flip it over. And now we can solder that in. This board is a PC Engine GT, I'll show you in a second. The white one is the one I've designed. And the green one is a customer's that is having basically everything swapped over to this new board. But there's also potentially problems with it because it didn't work for the customer in several ways. They haven't paid for the diagnostics, so if there is issues after transferring stuff over, they might have to, well, they will have to pay for diagnostics, but it might be the transfer over fixes all the problems, so it's still worth doing this. And then in the process, what we're doing at the minute is taking off every component, measuring it and figuring out exactly what it is, so that we can, instead of me having to do this every time I do this job, like fitting all of these components, which is mind-numbingly a lot of, I can have the factory do all this for us. So all of the, you know, transistors, resistors, diodes, inductors, all of them can be pre-soldered at factory. And then when you want to do this work yourself on, like, you know, this board, you'd only have to swap over main chips off the PC Engine and not have to swap over a load of other stuff. So that's what we're in the middle of doing. Thanks, Joseph. Glad you think it's nice. We're trying to keep this almost, the goal is to make this almost like factory, so that when we finish working on it, it looks like it's been assembled at factory. So far, I think we haven't done a bad job. I think it looks nice and clean. Maybe he wants slightly moving to make it, you'll think it is factory, but yeah, I think it's going nice and clean so far. 506 we added, F500 we've added. Right, so in this area now, for your iron as well, Dave, if you're struggling with the temps, just make sure you get a good iron. The iron can make all the difference. It can tell you it's at 400 and it's not, so it's also how much you trust the iron that you've got. They're now that cheap on AliExpress. If you search for I2, I think it's I2C, this is like a JBC clone, one of the most expensive brands. Go for an I2C iron and it comes with a C245 tip, and these are JBC. You can buy real JBC tips then, but these are not expensive. I think you can even get these now for like £60. It's crazy, whereas this was like 200 when I brought it. But yeah, I'd get a decent iron if you're going to do it at all serious. Just spend that little bit of money, because there's nothing worse than trying to use a shit iron and thinking you're bad at the job, and it's more than likely going to be the iron. Evening, Andrew. Where are you at? It's something in the morning here. Don't know where my clock's gone. I haven't even got a clock. Ah, there. 7:30 AM where I am. Hey, glad you like the Doom chair. Right then, what is next? We're on these caps. So whether I don't really want to, well, actually, yeah, in one way, we kind of probably want to do the caps because they're missing off here. Like, these are terrible. The customer's attempt, I think this is like, I want to say that's the customer's attempt. They're using Chang'e caps and they're not soldered, so that's just not good at all, and they're all floating off. But these are caps I'm going to replace with ceramics anyway, so I don't really need to reverse engineer these, because these are known values. We've got a cap kit, so I can just take them off the cap kit and get them all on. So I'll probably whiz through all of these components and make notes, but I literally have a cap kit with the notes on, so let me just pull up that, and then we can get a bunch of components on without having to measure them. Where's it at? Retro 6 docs, cap kits, PC Engine GT, and yeah, they're all there. Stoke accent it certainly is. Right, so we will start with, where can I get this up? There's no space, I'm going to have to keep tab in between, which is not the end of the world if I do that. Right, so CC100 is 100 microfarad. So if I get, I'll put the caps back under here. I could have sworn I left them out somewhere. Yeah, now I've left them out and I don't know where they are. I left them out because I always use them, and now I don't know where they are. There. So we'll do 100 microfarad cap. 2:30 AM here. Yeah, I think you're worse than me for staying up and not getting sleep. Not doing too bad. I'm just doing probably another hour and a half. Just chunking away at this in sections and doing other work in between, because it's quite mind-numbing to do what we're doing. Slowly reverse engineering a bunch of stuff, taking components off, plonking them back on. Tweezer irons, yeah, I used to have them at the start. It's one of them things where I think you feel it's beneficial and it'll make jobs easier. Like I think at the start when you're trying to learn the soldering, you look for tools to help your job, but personally I don't think it's worth the desk space and the time to switch between irons. If I had a nice setup and a proper JBC with the dual setup that's nice and quick, I'd probably use them just for like whipping off caps and things, but that looks quite nice. That's almost what factory finishes are meant to look like, that nice little fillet there. I never get that. That is accidentally quite a nice one. Yeah, I just don't think the desk space for the benefit of the tweezers is worth my while. I hot air a lot of stuff off, and if I'm just getting them off to swipe off, I just put the tweezers to the side and rub up and down instead of needing two tips. But yeah, they are useful. I don't have much desk space with every other tool I've got on here. Next up, CC103 is another 100 and 104 is 100, so these two can be hundreds as well. This tip is going to slowly die, but I should order one today because I can see this dying. I think it's the handle, not necessarily the soldering iron tip. I think my handle's bending and breaking. It's the only downside with the cheap irons. They don't last as long, but they also only cost about £20 instead of 700, so still worth it. You don't need polarity on these, so the positive is if you're using the original aluminium electrolyte caps. Ceramics aren't polarised, and the circuit design doesn't need them to be either. So in this case it doesn't matter. There is no polarity on these. Right, CC101 and 102 are 33 microfarad. So these can be 47 uprated because 33 in aluminiums, it's not going to be anything specific on the filtering. This is going to be more of a stability cap, a bulk cap if you will, and ceramics tend to be a little bit down rated on the capacity versus aluminiums. So when you're redoing the circuit with ceramics, sometimes depending on where they're used, you want to slightly uprate them, and 33s are not that common anymore. I rarely see a circuit in modern tech that uses 33. I think back in the day 33s were just the 47s of the day. They were the ones that could be manufactured at a good price point at a certain size, and now the 47s are really, they take that spot. So unless you have a circuit that's requiring specifically 33, I'll tend to use the 44s, and I've done tons of these, so I know they work. There's no issue with this at all. Morning, welcome in again. And you see what I mean about how many more people we have on TikTok versus everywhere else. It's like we get, obviously I kind of grew the audience there though, I suppose, but we get so many more viewers on TikTok than anywhere else. But now I think the chat's working much better now we've merged it in properly. Anyway, let's check out them fillets. Bring them up, focus in. Yeah, look at them for nice little finishes. I'm impressed with them. They've worked really nice. Like I said, I rarely go for, you know, overly visually pleasing finishes like on the solder blobs. I don't normally care how much solder I put on, but those look really nice. That's them 4 caps there. So we have the DC jack, which I think I ordered. Yeah, I ordered. I've just got it from AliExpress because I've got quite a load of stuff coming at the minute, and there's no rush for it. I've got the 3.5mm jack on its way, so we'll put that in when we need to, and the switch, but we wouldn't put these two in yet anyway because they're plastic, and we've got all this to do on the back side, so the plasticky stuff will be put on last anyway. So moving down from them, we have the audio jack, which again we're not going to put the audio jack in because it's plastic, so we can probably go 2. So let's do these here. Tinning pad 1 and dragging in. You can do that with a soldering iron. Takes longer, not as clean. Certainly a technique, but I like my hot air. I hot air most stuff. The hot air will melt both sides evenly, let the flux and solder flow and the component fly into position. So it's a much cleaner way of getting them to naturally, you saw how these pulled into position and the fillets are perfect. You wouldn't do that with a soldering iron unless you're a lot more skilled. Whereas with a hot air you don't need to be that skilled to get that finish. Right, C703. I don't have that in the cap kit, so we're going to have to measure that in the LCR meter. And 703, where are we here? So we will take him off, or we'll slide him to the side. And actually, no, we don't need to slide him to the side, do we? Because the LCR meter is easy enough to tap on. So we'll just take him off. There we go. Get that back into view, and now the goal is with the LCR meter, you got these big prongs. What you can do is these have 2 pins each. I can remake it so I can just grip on and it's accurate enough, but technically because these are proper, they have 2 pins. One is for the H pot and H current, so you've got a potentiometer and a current pin going in and a guard. So it's basically keeping it accurate, but you can do it without that being super accurate, and I could rewire these so I can just use a single gripper to grab on. I've done it before, so you can just like grab over the component like this, but you actually need to use both ends here. So if we tap over here, we'll tell it it's a cap, give it a helping hand, so we're not waiting for it to auto calibrate. If it's a small cap, the frequency won't matter too much. So that's saying 130 nanofarad at 1 kilohertz. So we'll change the frequency. I like to measure in general small caps, if you know it's small caps, at 100 kilohertz. It's a nice average one, and it's what often a lot of the tests will officially rate them as. So that's 116 nanofarad. So my guess is that's a 0.1 microfarad. It's going to be 100 nanofarad and it's just reading slightly over. because the idea of 100 nanofarad is to filter out high frequency noise. So if we set this up to, I think that's the highest test this goes to anyway, 100 kilohertz. That's why it's tested at that. It's reading, 0.11. But it's not going to be 0.11, it's going to be a 0.1 microfarad, so 0.1 UF. So very common, that's for filtering out high frequency noises. We can chuck him back on the circuit, we'll place him there in a minute. I'll just make a note before we forget. We don't need to make a note of the other caps because I've got the cap kit. I'll add that to the bill of materials when we're done, so I literally don't need to write down those ceramics we just put on. But C703 is 0.1 microfarad. Now soldering onto the board, and move this out of the way. Solder on either pad, tiny bit of flux, and hot air it down. There we go, and you see the hot air, you might have to plonk him down, he didn't quite catch. Once he melts into the solder, it'll just naturally pull. You can nudge it and it just stays in position or pulls back to position. Oh yeah, you're not wrong there, Andrew. And the older they get, the worse they get. The high frequency noise will be coming down in about half an hour for a coffee as well. We can use that as code name. As long as they're not on the stream right now, they don't know that's what we're calling them, so I can use that as a code name going forward. See if the high frequency noise is awake. Alright, 723, let's measure that one as well. Too old for TikTok. Yeah, I just used, I don't even know what got me into it, but for whatever reason I got into it and started doing little videos on repair, and honestly I've never seen a platform blow up as much as TikTok. Like, the YouTube for me has always been, I've done it for years and years and years, even in the software. Like, you get no traction, or I don't, at least what I do just doesn't seem to get traction at all on YouTube. This is probably the most traction we've ever seen on YouTube, and you can see it's pretty much dead at the minute. It's died down again. We were up to like 30 or 40 on the horizontal, and the last couple of streams have been lower and lower. But then look at the TikTok at like 156 viewers. So the TikTok just worked for me. It seemed to be the platform where people most found me. Right, so this one we can measure. Now this one's 150 picofarad. This one's measuring. So we'll set the frequency to 100 Hz. We'll do a measurement in a few ranges. That's now measuring 2 nanofarad, which is 200. Actually, let's take this off the board completely, because I think what we at that lower range, I think leaving it on the board, we're getting a little bit of potential capacitance from the traces on the board. So let's. Don't know why I left it on. I was thinking it was a resistor for a minute then. A tissue? What do you mean by a tissue? This studio light does me head in, the angle of it. Hey, welcome in from Nigeria. Got people in from all over. Right, this is on 100, so this is a slow 100 Hz. And it doesn't measure anything, but considering we know it's low, we're going to go straight to the 100 kilohertz because it's obviously a small cap. Yeah, I think this cap's potentially bad. There we go. So I've got 1.5 nanofarads that will be. So let's go to, say, 100 or 10 rather, 10 kilohertz. Yeah, right, that's consistent now, it's clean. So 1.5 nanofarads. Slightly non-standard. Let's see if maybe the PC Engine's schematic, the desktop version of this, see if we have any caps that are in a similar range and in a similar area, just to give us a bit more feedback on that so we can make the right choice. If not, the reading will be accurate enough, it won't be a problem. What do? I repair retro consoles, I make retro console hardware, we build and sell them, and a bunch of other stuff. Alright, so I'm just going to scan through the desktop PC Engine schematic, just in general looking for some caps that are very low. I don't know where this is at. Oh, it's going to be the crystal. It's right by the crystal. So if I look at the crystal circuit on the PC Engine, it'll be probably, although that's quite high for a crystal capacitor, it's almost likely going to be related to that crystal. So this is going to be pretty important to get right, if so. Come on, where's the crystal? I haven't seen the crystal. Boo boo. Oh, it's because somebody's drawn a crystal in a very strange package shape. 33 picofarad on that and not positioned on that, so it's not that. Right, let me go to the PC, what do I even call it? boardview-pce.retro6.co.uk. I might just put this down as, for now, the 1.5 nanofarad with a question mark, because other than the tester measuring, you can't be any more accurate. So it'll work at that, but I've got a feeling it's standard capacitor values in nanofarad. Let's have a look at the most standard range. So standard ranges in nanofarads. The low end are... There is a 1.5 nanofarad at standard. There's a 1.2, 1.5, 1.8. So it will be then 1.5 nanofarad. I kind of want to see a bit more detail about where it's going, but I've got to trust the equipment, and that is literally where that's what it's measuring, and that's where it's telling us. So let's make that note. And it's C723, 1.5 nanofarad. And these are the kind of caps that if you're using a cheaper LCR meter, you'd never get this accurate reading, and you'd be way off. And they're one of the things where you really need that accuracy, because if this is related to this crystal here, it'll be related to the oscillation and the stability. It's a crystal load capacitor, it'll be at a guess. So it loads down this crystal and makes it oscillate correctly, so it's a crucial value. The fact it's right by the crystal, I'm almost guaranteed it's going to be that, and there's not many more uses on this board for such a low value capacitor other than very high speed crystal circuit. Nice, sent us some values in the Discord. What we'll do is I'll still make this list myself, because this is the whole point. I want to see for myself that it's definitely right, but we'll use it as a good cross-reference. So if other people have already done some of these and done the same test, we can use it as like a double reassurance and a cross-reference, and if they match, they match, and if they don't, we could find the ground and retest and figure out, you know, what's what. So that'll be handy, but I'll still definitely be I'll still have to test it myself, if you know what I mean. It's the same thing when I make cap kits. I always figure them out, put them on myself, test the circuits work. I don't rely on notes online as well, because partly a lot of notes online are wrong. I'm not saying yours will be, and others it's just what I like to do. It's like I enjoy the kind of figuring things out, even if other people have. I enjoy the process. But I'll definitely check it out for a double cross-reference. Crystal we'll put on after we've put these three on, so I think we'll do that. Yeah, I think the new chat in TikTok's way better. I was missing, I think I've been missing tons of chat in TikTok because the integration with the other chat was like half and half. Sometimes it'd work, other times I'd see half the messages. This seems to be working really well, this Tickfinity it's called. It's really good, it doesn't seem to be missing anything, and it gives a lot more feedback as well. The tip I'm using, I've got the 210, I'm using the 245, so I can use, basically just seems to be more options on the 245 tips on the iron for different shapes and things, but I did originally use the 210. The problem with the 210 is when you come to do, say you're trying to desolder wick these pins off in the thick, the 210 tips aren't big enough and you can't get them big enough. Right, R720. Where is it? Here. Now, this one, I don't know if this has been knocked off or an empty pad. Let's see a picture online if this R723 has been knocked off by the customer. What I'll try and do is, I've probably... I've got a PC Engine board lying around somewhere, but not one on me. So I'll probably just look up a picture online quickly to see if we can find one. We are working on a PC Engine, so this thing basically, like a handheld mix between a Game Gear shell and a Game Boy Visual. So it plays all the Hue card games that the PC Engine did. We've got, put that up there so people can grab it easier when I come to show it off. This is the customer's original board in green that's all corroded and rotted and doesn't work. And this white one's the one I've made and designed. And we're transferring very slowly every component all the way over onto the board, working our way down this front side and then tackling this disastrous back side after. But we're testing every component as we go, every single component, to measure the values and figure out what they are, so that we can have the factory assemble the boards for me in future, and I don't have to do this every single time, like swap all the resistors and caps over. I can get most of it pre-assembled at factory. Let's see if I can find a picture of somebody's. Right, there's a random picture on... no, it's gone. Need to find a zoomed in enough picture on Google that I can see it. This is one thing I did want to add to the wiki as well, as daft as it sounds, just an actual photos of the PCBs, because how many times I have to look randomly online at other people's pictures to see if they're actually, you know, there's components on. It's crazy. So save to desktop. Open up the picture, zoom in. Right, no, so that component is missing on a random photo of another guy's, so we can be pretty confident that is just an actual no-fit component that doesn't get installed. It's good to know. Where's my... Wicked, my camera switcher buttons decided it's going to hide now behind the screen and not sit on top. It does this sometimes. Let's just reposition that there then. It wants to play like that. There we go. Right, have I missed anything? Nope. Next up then, we are back to these two resistors. So again, we can read what's on them and then we'll still measure them to double check. But we have upside down. Now I've got them there. So this is 8 to 1, so that'll be 820 ohm resistors. It should be. What I'll do there is measure them in circuit, because we've got the double check that the resistor values are written on, so it's unlikely to be wrong. So we don't really need to go to the extremes of taking them off and measuring them out of circuit if they also measure what we expect them to. Yeah, bang on 820 ohms. So that is definitely what that one is. And then all we have to do is we'll prepare, where are we? these pads here with flux and solder. And again, let's try not to put too much solder on the pads because the resistors are coming off the other board with a little bit of solder already on them, and they end up bubbling up. So tiny bit on there. We'll put that way. We'll get this board that way. There we go. And then we'll just hot air them off. So I don't know whether you can see both just about there. Just about fitting both in frame. Yeah, the little light counter's working. Liam's in and getting them lights in. You'll notice we've added all of these new TikTok features now, so we can actually see what's going on in TikTok instead of it just being like we don't even have a clue what's going on. That's that one on. Swap the other one. There we go. Morning, welcome in again. Anti-static mat, it's the size from the biggest, so it's not the double XL. Let me just quickly go into orders, mat. It's the XL Leash Boss. It's 64 by 43 centimeters. Confirmed C509 4.7 in Retro 6 board ID. C509? Have we done 509 yet? Or is it one of the big ones we're on about? Oh, as in the ID, sorry. C509. It says C905. Have we done that as well? C901? I don't see either. Where's that? So which one are you on about? Sorry, with that C509 or 901? Can't see one anywhere. Not that we've installed anyway, so we haven't got to the point of obviously doing that. C506, 510, 511. Where is 9? The only one we want isn't there. I mean, it could be on the back side as well. There's loads. C512. But yeah, just let me know what you're meaning with that cap, because I don't think any cap we've done so far is that. So obviously if we haven't got to it, when we get to it, we'll test. Right, these are a resistor pack. I mean, there's not ID. I'm still missing something there. I think I'm still not 100% sure what we're on about there, unfortunately. Probably too early morning. So these pads here are basically 4 resistors in a row. They're usually 10k on quite a lot of them, and they're common to fail and stop the game loading. So if we pre-tin them pads, and is this iron working yet? We ideally want these to go over, otherwise hand soldering 4 individual resistors is a pain. I'd probably end up just ordering the resistor packs and waiting if so. So let's take a look at this. And these are basically just 4. You could use like 4 0402 resistors on here if you wanted. Is that fully zoomed in? Yeah, we're maxed out on the zoom. So digital zoom. And then that is, let's pull focus. Is that 820? Yes, they're going to be 820 resistors again, I'd say. And to test that, we will get the multimeter on and measure one, and they all say the same, so this is just going to be a string of 820 ohm resistors. And we'll measure them all actually, because if one's failed, this board isn't going to work. So yep, 820, 820, 820, yeah, so they're all good. So we can transfer him over just the same. I'll hot air him off. Yep. And then hot air him on. It's much quicker than doing 4 resistors. I'll just tap up the corner resistor there. It's got barely any solder on. In fact, you could also clean the iron and just go down them, because they weren't well soldered on the original board, so they're not carrying much solder over to this board, so we'll just tap them up with the iron as well. Get a nice bead on there. That's it. Ah, yeah, okay, yeah, the 509, when I come to it, we haven't soldered it on. I'll double check. Are you thinking like the silk screen's wrong or something? Or just on the board, but I'll look at that after. We'll surely come to it. I can see 510 and 512. 506. The bigger ones are CC. I think that's why they do CC. Normally it's the larger cap, so it's none of them. So I think it's on this side. 720, 100. C509 found him. So this is C509, and I presume it's this one here at a guess. There's L1 will be that inductor, 100's that inductor. CN's the connector. This is the connector here, which will be something else. The L is there, so C509. That is on this side of the board. Ah, yeah. So we got a silk screen wrong. That's what you're on about here. So that's something I'll correct. It's not the end of the world, because I don't think there's a 905 on the board, but yeah, good spot there. So the 905, I never even spotted that with the 509. I looked at this over and over as well to make sure it was correct, but I'll fix that on the next batch. And luckily, if we're doing this work, all these are going to get sent to factory anyway, like these existing boards, and they're going to have the caps installed there, so you won't even, like, you wouldn't make a mistake anyway, because they're going to be pre-installed. That's up to there. I am going to now crack on with some software. I've got to get all the work ready. I've got to do some software, and then I'll go for a coffee as well. And I'll probably be back on later, even if it's just for a few hours, to just keep eating away at this board. And we'll work through getting this all finished. But we've got a little bit accomplished there. Nothing crazy. We've got the 2 transistors on. We've got the potentiometer, the resistor, some of these caps, that, them and that, and they're all measured, tested and written in. So it's slow progress, like I say, but we'll work our way through it. And then that side, I think, like I say, I could do with pulling a long all-nighter. I don't want to waste the time in the day doing it, but I could blitz through this off camera as well. On some things I could just write the notes down. The stuff you've seen, like the resistor packs, I can blitz through some of it, you know, get it going. But I'll try to do most of it on stream, because it's just nice and casual and people seem to be enjoying it anyway. So I'll save me a little Excel spreadsheet where we're up to. Oh, actually, before that we didn't add, we added none of them resistors. So I didn't do R720, R719, and R723, is that going to be? No, it's going to be 718, it's the resistor pack. R718. So that's 820 R times 4, and the others are 820 R. Got to try and make sure I don't end up doing all this work and forgetting to actually write down what components are. So C723 was the one before, yeah, that's all them on. Yeah, glad you liked it, and definitely seems like the TikTok integration works straight away first time as well, which is good. Audio I've improved massively again, because I had a it's decided to mute it when I open that up. I've got a denoise, a EQ and a compressor on the audio. It wasn't even running until 2 days ago. I thought it was always running, it was never running. As soon as I enabled the denoise before, it was a bit too much, it cut out some of my voice. So now, obviously, it's pretty much natural. If I turn off the denoise and EQ, that should be now, that's the raw mic that we were listening to up until now. So that's just literally this mic here with no filtering. But you'll hear the background, I presume now you can hear that background fan if you've got headphones in. So you'll hear like the noise. So the denoise now gets rid of all that noise without affecting the voice. And then the EQ and compressor just improves the voice and makes it a bit more easy to listen to, basically easy to hear. But yeah, I've put a ton of time into getting the audio working good, so I'm glad it's working. What software are you using for this stream? I'm using Streamlabs. I'm using quite a lot. I've got Streamlabs with Streamlabs overlays. I've got Tikfinity for the TikTok integration stuff and the chats. So yeah, audio's been good, and then mute. When I open Wavelink, for the audio processing I'm using Elgato Wavelink. Works quite well. I've got a full professional setup for the audio, but again, like a lot of things, using the prosumer level stuff is actually a bit more convenient sometimes. So I do actually have like an XR that can filter and do all the audio through real analog circuits, whereas this is actually just running through software through Wavelink, and then I'm applying some VST plugins for denoise and EQ and gate and stuff. But yeah, that's it guys. I'll jump off now and I'll catch you in a little while. Thanks everybody for joining.